Hey everybody, the purpose of this video is to walk us through some solutions for our confidence intervals, T intervals, for an average weekly amount spent by Americans in December 2010. Data is a little bit old now, but not the biggest deal. It's not so much the age of the data as it is the analysis for this. If we were trying to make predictions based on this, it'd be a different story, but it's just techniques. When we're learning a technique about how to make a T interval, it doesn't really matter that the data is 3.5 years old. Anyway, first thing up, based on this random sample of looks like maybe 30 or 40 Americans, what's the 95% confidence interval for the weekly amount spent by Americans among those in the population we're studying? Okay, so what we're going to do is we're going to use an old 243 skill. We're going to fire up our TIs. We're going to get our stat editor out. Looks like I got some stuff in here. We're going to clear out. We're going to need two lists. I'll go ahead and clear 3 of them so you're not distracted. And in the L1, we're going to place the midpoints of each of these groups. 62.5, 67.5. The reason we're doing this, as you might remember from 243, is it's all we can do. If we're trying to get an idea, 82.5, 87.5, 92.5, and 97.5. All right. It's the best we can do. I mean, we don't know how many of these 8 people spent $65, spent $70, spent $65.50. All we know is we can call them all on average 57.5 and get away with it because of the law of large numbers. Frequencies go in here: 118885240 There we go. We got our data in now. And the first thing I want you to do is find the confidence interval. We can use that to discuss. So let's find it. So we're going to go to, clear this out, go to your stat menu, over to tests, and your friend, when you're talking about averages, is called the T interval. We do have data. The data is in L1, but the frequencies are in L2. At 95% confidence, we can be confident that between, what did I tell you to round to? Round to the nearest dollar, between $72 and $80, plus or minus. So the margin of error is $4 on that one. On average, they're spending 76 plus or minus $4. And, that's believable. If you look up at the graph, that puts the average right about here. A little bit long on this side, not so long on this side. So I think we're happy with that average. One point, the data above doesn't seem to be exactly bell-shaped. They're normal-ish, but not perfect. Why is it okay to run a T interval anyway? One of the big assumptions that you should make is that you've got roughly bell-shaped data. If you're unsure, I get the idea of bell-shape. It's got a little secondary hump over here. So you might be concerned that these guys out here are outliers. If that's ever a concern, go take a look. Go take a look at a modified box plot. Set it up right, L1, L2. And then we'll do a little zoom 9. And, there's your data. There's your data. If you want, you can turn the histogram on with it. Let's turn the histogram on as well. Turn it on, histogram, L1, L2, zoom 9. Okay, we'll finagle a smidge. Looks like the min's 55, max is 105. And the scale is 5. I'm making the TI match the screen over here. There. There we go. And we can, just to make the window a little more presentable, we'll make that pop up. There we go. So there's your data. And here's a TI look at it. The reason why I don't care that it's not perfectly normal is that there are no outliers that are ridiculously affecting the average. It's not getting pulled excessively to the right because of these guys. So these are large values, but not excessively large values based on relative position. You can do a similar analysis based on standard deviation if you wanted to. That's one answer. Another answer, it's a fairly traditional answer, is it looks like we have, let me just real quick take a look. Yeah, we got 32 data points. So, technically speaking, you've satisfied the quote-unquote n equals 30 rule. But again, that's a guideline that's been handed down over the years, and I'm not even really sure why it exists anymore. So I like, rather than looking at that, looking at the data itself and saying, oh, look at that, no outliers, therefore the average is a pretty resilient indicator. According to this Gallup poll, the average weekly spending among the same group in January 2011 was $58. Is the headline accurate? U.S. consumer spending down in early January. Well, yeah, I think it is. I think it is because $58, that's going to have a margin of error as well. Okay, that has got to have a margin of error. Okay, so yes, the answer is yes. Why or why not? Because if you take the $58 and apply a margin of error, and what margin of error to use? Why not just use the $4 from the previous one? Okay, even if you add $4 to 58, it's at 62. Okay, even if it's a 62. Well, looking back to our TI, 62 is still $10 below the lowest point of the T interval from December. So we've dropped minimally $10 in consumer spending per week at 95% confidence. So yeah, because even with a margin of error of $4 added to this $58 that's here, it's still below it. So the intervals do not overlap. They do not overlap in this case. Looking at it graphically, if you were to place the, let me just get this a little fancy here. If you were to place the confidence interval for December 2010 on this graph right here, we'll do it with red. We said it was 72 to 80, which is essentially right here. There's the confidence interval for the mean average expenditure of an American. Okay, mean average expenditure. Okay, now we'll change the marker to blue and we'll do the mean average expenditure from an American in January of 2011. Well, that started at 54, which is actually off the chart a smidge, up to 58 and over to 60, what we say it was 62. There is the confidence interval for 2011 January. Clearly non-overlapping. The parameter value at 95% confidence is significantly lower than the parameter value up here in December 2010. So hopefully that made sense. Good little analysis of our data, and we'll catch you in class.